In the first half of the 18th century, bike tires were made of wood, then metal, and after that, solid rubber. Finally, in 1888, a Scottish veterinarian named John Dunlop developed an air-filled rubber tire to give his son's tricycle a smoother ride. The air-filled bicycle tire continues to be the hottest thing on two wheels, but a modern spin on the concept takes it into the 21st century. Computer designed for minimal road resistance and aerodynamics, the inflatable bike tire has had a major update. Additives such as mineral oil, sulfur, and carbon black make the tire more elastic and durable. And they use a combination of natural, synthetic, and recycled rubber. They weigh and bag it and send it into an enormous hot mixer. The white blocks are the synthetic stuff. Other ingredients include anti-aging agents. During the mixing, a chemical reaction causes the plastic bags to disintegrate, leaving only the desired elements. The components melt into a rubbery dough, and rollers squeeze it into thick sheets. This rubber sheet will now be used to make the tire, beginning with the tread. Narrower strips enter an extruder. It heats the rubber to soften it and takes it through a die to form a strategic profile for the bike tire tread, leaving it thicker in the center and thinner along the edges. The tire tread rubber now takes a long, cool dip in a tub of water. This solidifies it, setting the profile shape. An automated spool winds it up, with a fabric separator between the rubber layers to keep them from sticking together. In the meantime, rubber for the bike tire casing has been reinforced with nylon mesh. This casing rubber now enters a cutting station. Blades slice the casing rubber into strips that are the correct width for building bicycle tires. It will take several to build one tire. An employee pieces all the strips together for production. He winds the assembled strips of casing rubber onto fabric backing. Neatly rolled onto spools, the rubber can be stored until the tire assembly. And they're ready to roll. An employee winds the nylon-reinforced rubber around a metal drum. She then applies 2 strong Kevlar threads for the tire beads. The beads will hold the tire to the wheel rim. Once in place, devices fold the rubber at the sides over the beads. She then wraps a Kevlar strip around the tire casing. This is for puncture protection. A machine now rolls the tread rubber onto the Kevlar strip. With all the layers of the bike tire in place, she removes it from the drum. Then it's over to the branding station. This worker arranges labels on the tire rubber and bonds them to it with hot metal plates. The next employee places the tire rubber in a clamshell-like mold. This mold contains a large balloon or bladder. They pump steam into the balloon, causing it to press the rubber against the sides of the mold. This shapes the tire, including the tread, and fuses all the layers together. It also transforms the tire from limp to rigid in a process known as vulcanization. And it's quite a transformation. This is the tire before vulcanization, and this is the tire after. One tire from the batch undergoes a gamut of tests. This one simulates road wear. The tire spins against a metal wheel until it goes bald, usually after several thousand kilometers of spinning. This confirms that the tires from this production run are long-wearing and can go the distance. They also test for puncture resistance and pressurization. If the bicycle tire passes all the tests, this batch is ready to test human endurance.